Today's lesson is about solving logarithm equations. When you have logarithm equations to solve, always check both sides are all logs. If answer is yes, then you need to condensing log both sides, change it into this format, then you can get the x equals to y. If answer is no, we do have some constant, then you need to isolate the log form on one side, condensing the log, change it into this form. Then change log into exponential form to solve for this x. But remember, you need to check the solutions because for some solutions are extraneous solutions. Now go to number 7. For these logarithm equations, we check all logs, yes. So we need to just condensing the log both sides. When condensing the log, here's the formula. If for addition of log, you go to multiplication of the argument. If subtraction, you need to divide the argument. If you have number before n, you have to jump at the exponent. That's the rule. Therefore, for number 7, on the left side, you only need to get the x times the x plus 2. On the right side, remember 1 over 5, you have to do 32 to the 1 over 5th power. Therefore, I got the log. Since we have subtraction, we have division line. 5th root of 32. Then you have 6 times, this 3 you have to jump at the 2 times the 3rd power. Then you need to simplify. Since we already got this format, log is gone. You will get the x times the x plus 2. For the argument, 5th root of 32, that is 2, because 2 to the 5th power equals 32. Therefore, 5th root of 32 equals 2. Then 6 times 8. 2 to the 3rd power equals 8. Then you get 6 times 8 is 48 over 2 is 24. Then this side you have to do distributive property because this will be the quadratic pattern equation. So we got the x squared plus 2x minus 24 equal to 0. Then we get x plus 6 times x minus 4 equals to 0. x1 equals negative 6. x2 equals 4. Then you need to check the solutions. How to check the solutions? We know that for y equals log base b of x. For argument, you have to make sure greater than 0. Therefore, we only check argument. For argument, go back to the original logarithm equation. We have x plus 2. So we get x and x plus 2. Then we got solutions. Solution, we have negative 6, you have 4. We plug these solutions into argument. Make sure it has to be greater than 0. If it's less than 0, then it's not your solution. So we plug negative 6 to x, it's a negative. So we put cross. That means negative 6 is not your solution. Then we go to 4. 4 plug into this x, yeah, it's a positive. X plus 2, that means 4 plus 2 is a positive. So we put a check. That means only x equals 4 is the solution. X equals negative 6 is not the solution. Now let's go to number 9. Still, we need to check all logs. Yes, all logs. So condensing the log both sides. For the left side, 2 jump, 1/2 jump at the square root of 9. 3 jump at the 3 to the third power. So we got the natural log. Subtraction means division. So we got the x minus 3 squared over square root of 9 equals natural log 3 to the third power. After you change into this format, then cancel the log both sides. You will get the x minus 3 squared. Square root of 9, that means 3 equals 3 to the third power means 27. You could say this is a power pattern equation. Therefore, you multiply by 3 both sides. You will get the x minus 3 squared equals 81. Then do the square root both sides. You will get the x minus 3 equals plus or minus 9. So x minus 3 equals 3, or x minus 3 equals negative 3. You get the x1 equals 6, x2 equals 0. Then you need to check the solutions. On the original equation, which one is argument? You only have x minus 3 is argument. How many solutions you have? It's 2. So we put 6 and 0. Plug in, make sure it's positive. If it's positive, you put a check. If it's negative, you do that cross. 0 is not the solution, and only x equals 6 will be the solution. For number 11, still you need to check all logs. Yes, condensing. On the left side, we only have log base 7 of x plus 6. On the right side, you got the log base 7 of 8x over 3x plus 2. Then cancel this log and you got x plus 6 equals 8x over 3x plus 2. We can do cross multiply. So you get the x plus 6 times 3x plus 2 equals 8x. Then do the for you. You will get 3x squared plus 2x plus 18x plus 12 equals 8x. We know this will be the quadratic pattern, so minus 8x both sides. You will get the 3x squared plus 12x plus 12 equal to 0. Common factor is 3. We can divide it by 3 both sides. Get the x squared plus 4x plus 4 equal to 0. Then you get x plus 2 squared equals 0. X equals negative 2. Then you need to check the solutions. We have 3 argument. That is x plus 6, 8x, 3x plus 2. We need to check negative 2. Plug in, yeah, this is a positive. This is a negative. That means no solution. Negative 2 is not the solution. So for this equation, it will be empty set. Now let's go to one more example. We have 14 plus 20 natural log of 1 over 5x equals 54. We check all logs. No. So move all log on one side, number the other side. You will get minus 14 both sides. 20 natural log of 1 over 5x equals 40. Then you divide by 20 both sides. So you get the natural log of 1 over 5x equals 2. Then we, using this format, change logarithm into exponential form. Base is e. So we get e squared equals 1 over 5x. Then you multiply by 5 both sides. So you get the x equals 5e squared. Then check the solution. You have 5e squared. 1 over 5x is the only argument. We plug in, yeah, this is a positive. That means this will be the real solution. Now let's go to number 3. Still you need to check all logs. No. Isolate the log on one side. Therefore, we minus 100 both sides. We got the 500 log base 49 of 3x equals 250. Then you need to divide by 500 both sides so that we can isolate the log. You will get 1/2. Then change this log into exponential form. You will get 49 1/2 power equals 3x. This will be 7 because for this part, that means square root of 49. Then equals 3x. Divided by 3, x equals 7 over 3. Then you need to check the solutions. You have 7 over 3. The only argument is 3x. So we plug in, we got the positive. That means this is the solution. Now let's go to 13. All logs? Definitely no. So isolate the log on one side. Move all log on one side. Therefore, I got the log base 2 of 2x minus 6 minus log base 2 of 5x equals 3. Then condensing the log base 2 of 2x minus 6 over 5x equals 3. Then change this log into exponential form. You will get 2 to the third power equals 2x minus 6 over 5x. 2 to the third power, that is 8, equals 2x minus 6 over 5x. Then we do cross multiply. You will get 40 x equals 2x minus 6. Then we solve this linear function. You will get 38x equals negative 6. X equals negative 3 over 19. We need to check this solution. We have two arguments, that's 2x minus 6, 5x. Then we plug in negative 3 over 19. We know this will be negative. Therefore, no solution for this equation. That solution will be empty set. Now let's go to number 14. We check all logs. No. So isolate the log on one side. We got the common log of x plus common log of x minus 3 equal to 1. Then condensing the log for this side, that's x times x minus 3 equals 1. We know for common log, base is 10. Therefore, we change log into exponential form. You got the 10 to the first power equals x times x minus 3. This will be the quadratic pattern. Therefore, we want to get equal 0. We got the x squared minus 3x equals 10. We move everything to the right side. You get the x squared minus 3x minus 10 equal to 0. And then we do factor. That's the x minus 5 times x plus 2 equal to 0. Then we got the x equals 5 or x2 equals negative 2. Now we check the solutions for extraneous solutions. And how many arguments we have? We have 2. So get the x minus 3. Solution is 5 and negative 2. When you plug in, you get the positive. We put a check. You get negative, then that's not the solution. When we plug 5 for x is positive. 5 for x minus 3 is positive. Negative 2 plug into x, that's negative. That means only 5 is the solution. X equals negative 2 is not the solution. Now go to number 19. We check all logs. No, we have this constant number. So we isolate the log. We move all log onto the left side. We got the 2 times log base 3 of x minus 7 plus log base 3 of 36 minus 2 log base 3 of 5 equals 4. Remember, when you move a term, change the sign. Then jump 2 over here as exponent, 2 as exponent. So we're condensing the log base 3. Since we have minus, we have division line. And 5 squared x minus 7 squared times 36, then equals to 4. This is the whole argument. Then we do 3 to the 4th power equals this argument. We got 3 to the 4th power equals x minus 7 squared times 36 over 5 squared. We know this is a power pattern, so try to isolate x minus 7 squared on one side. We multiply by 5 squared divided by 36. we multiply by 5 squared and divide by 36 so that we can reduce. You will get the x minus 7 squared equals 25 times 81 over 36. Then we do square root both sides. You will get 25 is 5, 81 is 9, 36 is 6, equals x minus 7. Reduce, you will get 3, here's 2. So we got plus or minus 7.5 equals x minus 7. We can get the x minus 7 equals 7.5. Or x minus 7 equals negative 7.5. So for this side, x equals 14.5. That's your x1. x2 equals negative 0.5. Now we need to check the solutions. We got x minus 7 is the only argument. Then we have 14.5 and also negative 0.5. Plug in positive, this check, this negative. Therefore, this is the only solution. This is not the solution. Let's go to 23. For this type of log equation, we see this is a quadratic pattern. We need to get the ax squared plus bx plus c equal to 0 form. Therefore, 3 times common log x squared plus 2 common log of x minus 1 equal to 0. Then we set up common log of x equals y. You will get 3y squared plus 2y minus 1 equal to 0. Then we do ninja x, negative 3 over 3 over 3, positive 2. Positive 3, negative 1. Reduce 1, 1. Then we put the y. Therefore, we got the y plus 1 and 3y minus 1 equal to 0. y1 equals negative 1. y2 equals 1 over 3. Then we plug back this common log of x equals negative 1. Remember, for common log, this is a 10. Base is 10. So we do this part. 10 to the negative first power equals x, which means x equals 1 over 10. For this part, that's y2 equals 1 over 3. Still, we need to plug back common log of x equals 1 over 3. Remember, base is 10. So we change into exponential form. That will be 10 to the 1 over 3rd power equals x. So x equals cubic root of 10. Then you need to check the argument. We have argument is just x. 1 over 10 and a cubic root of 10. When you plug in both positive, that means these two solutions are valid. For number 24, this is a quadratic pattern, therefore we try to get equal to 0. 6 log base 3 of x squared plus log base 3 of x minus 1 equal to 0. We will set up log base 3 of x equals y. So we got 6y squared plus y minus 1 equal to 0. We do ninja x, negative 6 over 6 over 6, positive 1. 3, negative 2. Reduce, you will get a 1 over 2 and a negative 1 over 3. So we put the y over here, and we got the 2y plus 1, 3y minus 1 equal to 0. y1 equals negative 1 half. y2 equals 1 over 3. Then we plug back. That will be log base 3 of x equals negative 1 over 2. Then change into exponential form. X equals 3 to the negative 1 half power, which means 1 over square root of 3. That is square root of 3 over 3. That will be the x. Now we go to y2 equals 1 over 3. We got the log base 3 of x equals 1 over 3. Change this into exponential form. We got 3 to the 1/3 power equals x. So x equals cubic root of 3. Now we check the solution. The argument is x. Then we have square root of 3 over 3. And we have cubic root of 3. Plug in both positive, which means both are valid solutions.